Hi, I'm Erica Hanoff, and I'm a student at the University of Colorado Boulder. And I'm going to present a work on proactive serverless function resource management. And I did this with Shazil, Vijay, Ali, and Eric. So like most talks, I'll begin with a background and work to frame the question we're hoping to address. And then I'll go into some details on our design, some preliminary evaluation, and I'll conclude with some discussion points and of course leave time for questions. Let's begin with the background. And we'll start by considering an example serverless application, which I've termed IDCat. So IDCat is composed of a single serverless function, which is going to take as arguments a picture of a cat and some user ID. It's then going to fetch some machine learning model from an external database. And then it's going to do some work based on the picture and the model. And when that work is done, it's going to write some sort of result to an additional cat database. If all of these things happen correctly, it is then going to indicate success. So our journey here really begins when we start to ask the question, how can we improve efficiency in this scenario? And the first thing that comes to mind are network connections. In sum, we want to avoid the cost of creating and tearing down ephemeral network connections, which is especially relevant to serverless since these functions are typically short-lived. The solution to this problem in other architectures, such as the microservice architecture, is typically a long-lived connection or connection pool. So in this case, instead of a serverless function for requests, we have these request handlers, and all of those request handlers use these long-lived connections or connection pools to access external entities. And not only does this save on connection time by avoiding additional handshakes and resource churn within the operating system, but it also allows the connection state to reflect changes in traffic as the number of requests scale. Serverless providers have currently found a mechanism to reuse network connections as well, but on a slightly smaller scale within a single VM or container. I'll just say container from now on for brevity. So during initialization, the developer can say that they want to define some what we've termed runtime scoped variables. And these runtime scoped variables are going to persist the entire length of the serverless runtime, which is tied to the life cycle of the container or VM. And so if you create these variables during a init, so this container VM is only going to service our single IDCat function, and it's only going to do one function at a time. So what this would look like is that the first time this function is triggered after initialization, it's going to use these connections. And then once this function finishes running, sometime later, there's a second time that function one is triggered, and so on and so forth. So if we have runtime reuse, which is very, very useful, we start to ask, where is there room for improvement here? Can we still work and gain some more efficiency? And that brings us to our freshen design. In a nutshell, we propose a new serverless runtime primitive, freshen, as a mechanism to enable proactive serverless function resource management. At least in OpenWhisk, there are two existing runtime hooks, init and run. So init is going to do what's needed to prepare for a function to execute. So that would mean, bringing in code or libraries that are needed to run the function into a specific VM or container. Run is going to actually execute the function. So what we'd want freshen to do is run before run based on some sort of prediction window. And there are a couple of policy options in this scenario. You don't necessarily have to have prediction in order to have this third, runtime hook. And if prediction fails, or if you choose not to use prediction, you could choose to run freshen in the function concurrently, or you could impose some sort of forced blocking where the function is only allowed to run once freshen has finished executing. So I want to summarize with this chart some of the ways we've talked about so far to manage resources and reuse in serverless. So if in the init phase, you can declare certain variables or fetch data, and those can be used throughout the runtime lifecycle. However, you don't really get dynamic state. And what I mean by this is that if a init maybe fetches some data and the container VM lives for hours, it's possible that data could become out of date. It's not dynamically watched out over by a init because a init only runs once. Now, you could also do this fetching or other things within the actual function code. So this would be like our very initial IDCAD example where the function itself goes ahead and fetches the ML model each time. And that will be up to date, so we get this notion of dynamic state. Runtime reuse, which we covered last, kind of combines the two of these. It uses these init defined runtime scoped variables, but then it manages their dynamic state within each function application. But that management can cause additional latency. So what we want to do with Freshen is by changing the time so it runs proactively, you could do these tasks without really affecting the latency or the duration of your function. However, to be truly proactive, you would need some sort of notion of serverless function prediction. And function prediction is useful for a wide variety of reasons. Scheduling, resource utilization, cold start avoidance, etc. So some things to talk about prediction. So we first observe that some cases are easier to predict than others, for instance, change functions. There are more details in our paper about these last 2 points, but we do observe that many applications consist of multiple functions. And the way that these functions call or invoke each other or are chained may lead to infrastructure overheads. And these infrastructure overheads could potentially be used to lengthen that prediction window we'd have in order to execute Freshen proactively. If we can't execute Freshen proactively, we can begin to ask, what can Freshen actually do? And to answer this question, we'll go back to our initial IDCAT example. So the first thing we'd want Freshen to do here is we'd want Freshen to prefetch some data, specifically the ML model. The second thing we'd want it to do is we'd want it to warm the connection. And what I mean by warming the connection is making sure it's established, but also making sure its external state isn't stale, such as the congestion window is ready for it to send and receive data. There are more things that Freshen could potentially do. And I'll talk about those a little bit more in the discussion section. All right, so let's move on to some brief points about evaluation. So I mentioned prefetching, and this graph is just essentially showing that the closer you locate the data to your code, the less latency you incur when you access that data. And this shouldn't be surprising to anyone, but it's good motivation for the ability to prefetch things. We also looked into how much can you benefit from warming a connection, and we observed that TCP connections that are warmed send traffic more efficiently, and this is of course detailed in our paper. Before I conclude, I'd like to go over a couple discussion points. So the first is that when I was talking about warmed connections, I mentioned TCP congestion window. So something to note about these internal connection state variables is that they're currently quite hard to access. So if you really wanted to implement this in some sort of production setting, you would have to start to wonder, how is the best way to access these? Do I need to create new system calls, or what other hooks would I have to make to actually control these things? Function prediction is a deep and very interesting and very useful question. So we look forward to working on that more in the future. You could start to ask who is responsible by Freshen. And by this question, what I really mean is who writes the Freshen code. So the obvious answer would be the serverless application developer, but it would be interesting if you could, have libraries that are commonly used by serverless functions that, have some sort of freshenable hook that can be integrated into the environment, or also maybe inference or auto-generated Freshen code. And also we want to think about what other actions could Freshen take, like memory allocation or the like. And that concludes our talk. Please email me if you have questions online. Thanks for your time.